Hello guys, this video I'm going to explain real quick what is the quicksort algorithm about. Okay, so with the quicksort algorithm, what I want to remind you, all right, is that this quicksort algorithm is going to be it's going to take the exact same steps as in the merge sort. So we're going to have a recursively, all right, path, and then we're going to have a merge, let's say, or a function, all right, that is that I'm going to explain later. It's not exactly the merge function, but it's called partition actually, but it works the same way. So we're going to have two sides of this. So as it is the similar, somehow similar to merge sort, is going to use the divide, okay, divide and conquer algorithm paradigm, all right, and then this also going to work recursively, all right. So now that we take that and look, we're going to do this first step, okay, these 4 steps, okay. The first step, all right, is select a pivot. The second step is put this pivot, right, put this pivot at the end of the array, obviously. Then we're going to execute partition, and then we're going to, if necessary, do the same, repeat from step 1. So this is the recursively side, or let's say the divide conquer side of quicksort. And partition, all right, I don't want to give you a spoiler, guys, but I'm going to explain 2 ways to partition, all right. The first way to partition, all right, is called Lomute, and the second way is called Tomihoare, all right. So Lomute, what is basically the difference here? They do the same, but the difference is that Lomute is almost is usually taught on college, and it's more logical and it has more steps. In my opinion, I wouldn't recommend doing Lomute, but I know that it is used there, so I'm going to explain anyway. And then this is my favorite one, the Tomihoare, all right, and which is, I think, in my opinion, easier. So let's first do this first step. So how do we select a pivot? A pivot is basically any item, all right. It's basically any item inside the array, all right. Sorry for my letter, I don't have a drawing pen right now. I'm doing this with my mouse. But anyway, we have to select any item inside the array. So imagine we have this item, all right. We have 3, 8, 2, and 5. All right, so we have to select any item. We could do a as a pivot, we could do 2, we could do 5, we could do 3, but that's doing poorly. All right, we're going to do this in a small way. We are clever, we are better than that. So what we're going to do is apply what is called the median of 3, basically. So we want to make sure the pivot is like the average, all right, number of the total items inside the array. So how do we select? How do we do this? All right. So first we select the first index value, which is going to be 3, and then we select the first index, the last index value, which is going to be 5, and then for the last here number, what we're going to do is basically sum the first index, so not the value but the index, 1 and 4 in this case because it's size 4. All right, so we sum those two and then we divide it, and when we apply this function here. So this function here is what is called the floor function, all right, or you could do a ceiling function, which is represented this way mathematically. So why do we do this? Why do we apply ceiling or floor? Because as you can see here, if we sum these two, we're going to select, we're going to end up with 5, and then we divide, it's going to be 2.5, all right? So you have to select a integer number. So it can either be 2 with the floor function or 3. These numbers represent the index, so we can have 2 or 8 in this case. All right, 3 being the index of 2. All right, because we don't have a clear mid number or mid item, so that's why we try to use either both of these. All right, so I'm used to applying the floor function. All right, so we're going to do the floor function. It's going to be 2, and index 2, its value is 8. So the last number here is 3, 5, and 8. All right. So what we put this in order. This is now in order from left to right, ascendingly, and we select the mid one. So in this case, it's going to be 5. So the first thing, select pivot, we do it already. Now we're going to put this pivot at the end. Now, it's a consequence. It is a consequence actually. I didn't see it, but the 5 is actually at the end. So we don't do anything there, right? We basically don't do anything there. It stays at the end. But make sure that if I were to select A as a pivot, I will put it at the end, all right, and replace it. So it would be 3, 5, 2, and 8, all right? But this is not the case. So now that the pivot is at the end, we're going to execute what is called partition, all right? This is the function, all right? We have 2 ways I explained to you. We have LOMUTE and TOMIHORA. I'm going to start by doing LOMUTE, all right? So let's start doing LOMUTE, all right? So with LOMUTE, what we do with LOMUTE is basically we take what is called a variable in programming. We take variable I and variable j, okay? And these 2 variables are going to be I'm going to start in the same index, in the first index. So I and j are going to be here, R and j, all right? Now we know that pivot is 5. So we're going to set these 2 conditions. All right. The first condition is that if this, all right, is true, if this is true, no, if this is false, all right, if false, then what we're going to do is that I moves. All right. But if it's true, then what we're going to do is I and j swaps, and then both move. All right. So these are the 2 conditions. If this mathematical comparison is false, then I move. But if this mathematical comparison is true, then I and j values, all right, values swaps, and then both move. All right, so you're going to understand this better with an explanation. So imagine that, so we start doing this, right? So we know that I is now in the index 1, so it's pointing to 3 value. So we're going to do 3 value, all right? This is the value here. Is this 3 less or equal than the pivot, which is 5? This is true, all right? So then we apply the second condition, which is I and j swaps, and then both move. I and j swaps, so that means the value, but we cannot swap 3 with 3 because it's the same, so it doesn't happen anything. And then both move, so I and j, they go here, I and j, all right? Then we do the same. Now I is not 3 no longer, so I is 8 now. So a is less or equal than 5. That is false. Then the first condition applies. And what happens when it's false? I only moves. All right. So I is going to move, and it's going to be here. All right. And then we do the same. 2 is less or equal than 5. That's true. Then both these values swap. All right. 2 and 8, they swap, and they both move. So that means j is going to be here and I is going to be here. All right. And then we do the same. I, which now the pivot itself, so it's going to be this comparison. This is true, and they both swap. 5 and 8, and then they both move, but I cannot move outside the array, so it ends there. All right, so it ends there. So we can say that we have already all right, execute one iteration of the Lomut partition algorithm, all right. So now, as you can see, the pivot is here, and if we do this, we examine, all right, the right side is going to be greater. You're going to be sure that you did this well. If the right side is greater and the left side is less than the pivot, all right. So now, while this is not ordered yet, so we're going to apply again Lomut. And how do we apply? That's when we apply the divide and conquer. What we do is divide the array in half, all right. So we have 3 and 2, and then we have 5 and 8, and we do the Lomut here and the Lomut here. We do the same basically. So it's going to end up like this at the end. They're going to match all, and this is the correct sorted array. Sorry. So this was Lomut. As you can see, it has some like it can confuse the conditions, all right. But it ends up with the correct answer. Now I'm going to explain to you the Tomi-Howari. Hopefully I'm pronouncing that well. Tomi-Howari way of doing the partition. All right. So I think this is more understandable and easy, easy to understand, and I prefer this one. And this usually this is usually the way we apply Quicksort. So that's why it's so famous, Quicksort. So what we're going to do is, after selecting and putting the pivot at the end, all right, we stay with the same array as before, and we're going to do is these two conditions, all right. So the first condition is first item, okay, first item greater than the pivot from the left. Okay, we select the first item greater than the pivot from the left, and then what we do is select the lesser item, or less than we select the first item less than the pivot from the right. That's it. That's the only thing you have to remember. So we select the first item, okay, the first item that is greater than the pivot from the left. So from the left, start here, and which is the first item greater than the pivot? 3. 3 is greater than 5, so that's why it's the first one greater. And then what we do here, we select 3, right? We put it here, and then we do select the first item less than the pivot from the right. What is the first item less than the pivot from the right? It's 2. So we have 3 and 2. All right. So now that we have 3 and 2, all right, what we can do, so actually this is wrong. It's not 3. I have to say that the first item greater than the pivot from the left is not 3, is actually 8. This is the first item that is greater than the pivot from the left, so it's A2 actually. So now that we have these two numbers, we swap, all right, we swap it. So it's going to be like this: 3, 2, 8, and 5, all right. And then we repeat the process. Select the first item greater than the pivot from the left, 8. The less item or equal, it can be less or equal than the pivot from the right, is the pivot itself. So we have these two numbers, and then we put it in order. We swap each other: 3, 2, 5, and 8, right? So now we do the same. What is the first item from the left that is greater than 8? And the other from the right to the left, is 5. But in this case, we see that item, let's say the item that we select from the right, all right, is on the left side from the item that we select from the left. So in this case, we stop, all right, we stop. We don't swap anymore. So we end up in a similar situation here, right? In a similar situation here. So what we are going to do, all right, what we're going to do is basically solve this recursively. All right. So we do the same. We divide in half, 3 and 2, and then 5 and 8, and then you merge. So you apply again in these two arrays the Tommy Hawk algorithm. So it's going to end up 2, 3, and then 5, 8 until it is correctly ordered. So there you have, guys. I rather do this, the Tommy Hawk, because I think it is easier to understand once you understand these two conditions. But if you want to apply it in algorithm in language, I would do Domute. I don't know. It really depends on you. So that was the quick algorithm. Hopefully you guys understood, and see you next.